Hey, lesson 55 is called Nets of Prisms, Cylinders, Pyramids, and Cones. It kind of goes together with one of the investigations I don't often do, which is drawing 3D solids. So we'll get through this just enough so you're familiar with it in case it ever comes back, or you have to do it on lessons or tests this year. But I won't get real picky when I grade these, and I don't think you should either when you grade each other's. When we work with solids, we generally think of 3D figures like this prism here, this pyramid, this rectangular base pyramid. If we think of it as a hollow shell, not as a solid, but one that we could unfold, you could cut it out and spread it out to unfold it. Basically, if you think of solids as origami here, this pyramid really becomes almost a star shape. If you can, imagine what it would be like flat. Basically, what we're doing is we're imagining 3D shapes like this, flat like this. And can you see how they came up with that? This being the base. As we see here, that's the base in the 3D model. And then these are the sides, right, in the 3D, so those are here. And they would come out extending from the base like this, so that if you wanted to put this back together, you just, wrap this up into, each of these would come to a point and meet to make this, right? This is called a net for this pyramid with a square base. In example 1, it asks, here's a net. What solid is this? Can you figure it out? To give you a clue, these are the matching bases. How could I make this 3D? What if we rolled this up and made these bases? We've got ourselves what? A cylinder. So then they say sketch the solid. Again, we're not going to get picky because we never really did this investigation maybe, but you make your bases and then you connect them. Maybe you've doodled enough in your time that you can at least get that much. Okay, it's hard on mine. You should be able to do better than that. Then it says, describe how the surface area formula below relates to each part of the net. Surface area is 2 pi r h plus 2 pi r squared. Well, which one's which? 2 pi r h would be this part, right? Because it's like the lateral surface area. I think this is the lateral surface area portion where we understand that this is basically the circumference of this as it wraps around. This is going to be equal to the circumference of each base. So that's 2r times pi. And then we multiply that by the height of the cylinder. Or you can think of it the other way around. I don't know, maybe this is the height and this is what's getting wrapped around. But either way, that's the LSA. This is the areas of the bases, which you need 2 of course. And that's kind of what I make sense out of this. I would just write that into 2 sentences in my homework. So it said cylinder. The first part applies to the lateral surface area because it's circumference, 2 pi r, times the height. That describes the surface area of this rolled part. And the second part is 2 pi r squared. Those are the bases. That's all you have to say. Which one, match it up, basically. All right, and then moving on to example 2. Triangular prism. Sketch a net. So it's just sort of a fun little puzzle. Can you figure out how this would unfold? And probably the simplest way is to take the bottom and put it right in the middle with these types, right? And then think, how would the sides connect to the base so that they could be reassembled, folded up into what it looks like? So you get sides 1 and 2 here attaching to the long edges. You basically identify what edges match up, right? And then you Make sure that that matches up in your net. And then add your triangles from here. And you've got 2 congruent triangular bases. Okay, they call these the bases. That's fine, whatever you want to call it. To me, this is the base because it's what's sitting. But 2 matching congruent triangles, whatever they are, sides, bases, whatever. And then 3 rectangular faces. These are really all equal to each other, right? 1, 2, 3. These are all equal. Okay, kind of fun. Example 3 has you sketching the front, top, and right side views. Then sketching the net. So if you look at this straight on, the front you see on the left there in the solution. And to the top, they've got it written weird here, space between the O and the P. Straight on to the top, that part's a 4x2, so we know it's a little bit longer than it is wide. And then a side is a 2x3, slightly taller than it is wide, but not as much. So you just want to reflect those measure relationships. Then to draw the net, what's fun and what I do in a chapel is the net of a box is always kind of this cross shape. But just to draw a quick, okay, I got this, and I'll draw my, I'll just go like this and this and that. That's my net. I'm just going to sloppily put my net. No, you have to make sure that the side relationships are about right. That, this looks about the right compared to this. That it's a little longer than it is wide. That this is wide like this. You have to think about how should this actually look. Okay, it should actually look similar to the answers in its proportions, not sloppy. That's actually not that bad. If you go like this, it's okay. It's a cross, but those are not the relationships at all. And notice they even label what is everything, the front, back, and so on. The net of a cone is kind of fun, simple enough, but a good thing to practice with. I'd like you to do this activity. Okay, show me that you've done it. And then let's do A, B, and D. A, B, D.